These days, a lot of people are talking about meta-analysis, and it looks like they believe that meta-analysis is the best thing that has ever happened to science. As a real scientist, I would like to carefully disagree, because I believe that meta-analysis is an amazing technique, but it has quite a few drawbacks and shortcomings. Let's talk about meta-analysis today. Hello, I'm Dr. Sam, this is Dr. Sam's Health, and today I would like to talk about meta-analysis. If you have watched my previous video, which was dedicated to paleo diet, you'll likely have noticed that my initial plan for that video was to talk about meta-analysis that would compare paleo diet to some other diets in terms of weight loss, and I actually did find one nice meta-analysis, but I quickly realized that first of all it had some drawbacks in my opinion, and second, I realized that in order to properly present the data in this meta-analysis to dissect this research study, likely I would need to talk about meta-analysis as a research technique first. So that's what I'm planning to do today, and prior to that, I will make my regular disclaimers. First of all, I'm a medical doctor, I'm a practicing physician, but it doesn't mean that anything I talk about here on YouTube or on my website, drsamshealth.com, should be taken as a medical advice. It is not. It is merely my opinion that I present in educational or entertainment purposes, and in my opinion, they tend to be well-intended, hopefully well-informed, but they do not necessarily represent the opinions of my regulatory bodies, my colleges, my universities, my profession in general. I'm a psychiatrist. Also, speaking about profession, I'm not just a medical doctor, I'm also a researcher, and as a researcher I've done quite a few meta-analysis myself, so today I'm going to talk about meta-analysis from the standpoint of expertise. I'm definitely an expert in that, and I do believe that it's a great research technique, but it does have some shortcomings that need to be taken into consideration when you read meta-analysis. So let's dig in. Let's start with basics. What is meta-analysis in general? Meta-analysis is a research technique that allows us to take data from multiple similarly designed studies and to combine this data into one statistical mathematical model. We call it pooling the data. And thus, this model allows us to come up with some sort of an aggregate result from multiple trials. The biggest question obviously is, why do we even need something like this? Why can't we just use the data from these studies? And the answer is very simple. Because there are multiple studies, and these studies, they differ. They differ in their setting, they differ in their timeline, they differ in their approach a little bit, they differ in their population. And obviously the outcomes of these studies, they also tend to differ. And sometimes these studies, they even produce some sort of conflicting results. So meta-analysis is the way of taking all the data from all these studies and trying to find some sort of a happy medium. And that's what makes this technique really beautiful. For example, recently I was searching for the data that would show how effective rTMS is for treatment of treatment-resistant depression. rTMS is a method of stimulating the brain using electromagnetic field. I use it in my practice, and when I talk to my patients, I have to pretty much explain how it works and what are the typical outcomes. And there are quite a few published clinical trials of this technique, specifically for treatment-resistant depression in different populations, and all these clinical trials, they come up with different response rates, different remission rates, different rates of different side effects. And if I were to rely on like 30 different clinical trials, first of all, it would take me a lot of time to find them all, and second, I would still have to somehow combine the data. So instead, I found a couple of recent meta-analyses that have already done this for me. They have already done all the literature search, systematic review of existing literature, found all the studies that they could use for this purpose, extracted the data, combined them statistically, and came up with certain response rate, certain remission rate, certain prevalence or incidence of side effects, and that is very neat, very convenient study for me. So that is pretty much what makes this technique so amazing. I don't have to work that hard to come up with a solid answer to the question that I have in mind. But this technique naturally comes with quite a few shortcomings, and I really want to talk about them today. First of all, and it's not even an inherent problem of meta-analysis as a technique, but rather something that is based on systematic review. In order to conduct a meta-analysis, usually you need to find this source articles somehow. In order to find these source articles, people conduct systematic reviews. And the systematic reviews, obviously, they can miss some studies, they can include studies that are not very appropriate, they can exclude some studies that we would like to be included. And that's the first layer of problems that is translated into somewhat biased or miscalculated meta-analysis at the end. The second problem is associated with research bias. As you likely know, every single article, every single published research, every single study has certain bias. It's a problem of research. It's impossible to conduct a perfect trial. So usually researchers, when they conduct their systematic review and decide to include studies into meta-analysis, they assess bias. And usually there are certain guidelines for assessment of bias, and they make a decision whether to include an article or not. But ultimately, all articles that are included in the meta-analysis have certain bias. And usually it's very difficult, if not impossible, to mathematically account for this bias. And because of that, meta-analysis tends to kind of ignore this bias. So the end result might be kind of oblivious of multiple research issues associated with each individual clinical trial or study in general. The third, and in my opinion the main issue of meta-analysis, is related to its very nature. As I said, we aggregate the data from multiple clinical trials or multiple studies, and we produce some sort of an average result. And often by doing so, we do not take into consideration differences in setups of the studies, in their settings, in their populations, and we might end up in a situation when we have a medication or a lifestyle modification approach that works for some people in some studies and it doesn't work for some other people in some other studies. And when we get all the data and we aggregate them, we might end up with some sort of a lukewarm result, slightly positive, negative, but this result is actually average, and it does not take into consideration the fact that some people have very unique properties or parameters that make this approach actually very helpful for them. And whereas some other people, they do not benefit from this approach for their own features or properties. And thus we would come up with some that is highly statistically significant, because meta-analysis, they tend to aggregate a lot of data from lots of patients or subjects. And at the same time, it's not clinically meaningful. I can give you quite a few examples, but I really don't want to waste a lot of time. Maybe in my future videos, when I'll be talking about specific meta-analysis, I will show it to you. And finally, we got the fourth kind of problem that is associated with meta-analysis. I have kind of alluded to it in my first three issues that I've described, but there is something that's called GIG or GIGO or GIGO, which stands for garbage in, garbage out, which is, I guess, self-explanatory. Often researchers find multiple articles, and each article or each research study has lots of bias. They are not really compatible, they are not of similar design, they have poor quality, and sometimes out of desperation, researchers still decide to merge them into one meta-analysis. Then they aggregate the data, they come up with some result, and this result is literally meaningless because of the low quality of the studies that were included into this meta-analysis. And that is our garbage out. So that pretty much summarizes the major potential problems with meta-analysis, and I hope that now you can see that meta-analysis is only as good as the studies included into this meta-analysis and the systematic review it is based on. And also I hope that me talking about this at this level of detail, obviously I could get into way more technical details, but I don't think there is much point in doing so. But I hope that you, as consumers of meta-analysis, would be able to actually look into actual meta-analysis and see if they have these flaws or these shortcomings, and whether you can trust that particular meta-analysis or not. And once again, I would like to say that it is a great research technique. It allows us to come up with really great, solid answers in some situations, but in some other situations, when the source data are not sufficient or heavily biased, meta-analysis can be quite misleading. And that's pretty much everything I want to talk about. My next video will be about this meta-analysis in paleo, I think. And it's time for me to wrap up this video. Thank you for watching. Thank you for being my subscribers. By the way, if you haven't subscribed yet, please subscribe now. Check out my website, drsamshealth.com. I'll have some blogs there. Also, hit the like button, ask questions, make comments. Please be active. Any kind of interactions are more than welcome. And once again, thank you for watching. Have a wonderful day. All the very best.